Hi there, thanks for joining me for another episode of Draw, Make, and Code. And in this episode, I want to be generating a mandala-like object using these tendrils. So I've created an object like this before. It was waving grass. I'll have a link to that video right here. It's sort of the same system, except for we have it kind of spun around a circle. So instead of it just being a flat line of grass moving back and forth, this is a circle. And the tendrils are moving a little bit differently. So the noise wave values are adjusted so that you can get this kind of elephant trunk looking shape out of each of the tendrils. And then you can offset that noise slightly so that each time a tendril is made, it's slightly slower than the one before, and it creates this kind of progressive output that you see there. So let's get to begin. We're going to start a new sketch. You can do this in the p5.js web editor, or you can do it in p5 live. It works in either one. In the global space, let's assign some initial variables that we're going to use throughout the program. We need an array to hold each one of the tendrils, which I'm calling arms. We need a number of tendrils that we can go all the way around in a circle in, and then we want those tendrils to be so big, or to have like a fixed scale for them. Inside setup, we're going to go through a loop that's going to let us assign the initial states of our tendrils. So we're going to create a new instance of each one of these tendrils, and then outside of the loop, just so we can start with some fresh output, we're going to do the background with black and full intensity. Then inside draw, if we want the output to persist or not, we can adjust the background here. I want to clear the background each frame so that we can see what's going on, and then we can play with that later on. Instead of hard coding the length that we're sending into the recursive part of this program, let's have a variable length that we send in. So each time we go into a recursion, we can adjust the length that we send into it initially, and that's what let length is going to be doing. Next, we're going to create our loop that's going to go through each one of our tendrils, and then we want to isolate any changes to the graphics attribute. So if we translate to a different position, let's isolate that inside push and pop. Then inside the loop, we want to access the X offset for each tendril, and we want to reset that to 0 so that we're kind of anchored to that same noise. And then we're going to go to the update method for that tendril, and we're going to pass into it that length variable that's changing, and then which tendril is it. And before we output that tendril, we need to translate to wherever we want to start our output. We're going to do it in the center of the screen here, and then we want to rotate around the center so many radians that so that our tendrils are evenly spaced around this circle. So that's what we're doing. We're rotating pi times whichever tendril we're on, and we're just doing 10% rotation. So once all that's done, we can go and do our function. I call it chain for whatever reason. I could have called it tendril or tentacles or whatever, but I just called it chain. It was short and easy, and that's kind of what it is. It's a chain of segments. In the constructor space, we're going to assign some variables. We need an offset. We're going to pick a random value for that so that they're not all the same, X offsets. I don't think it really matters because we're setting it to 0 up in the top, but if we wanted to change that, at least we're starting with random condition. The Y offset's going to be set to 0, and then when we do our recursion, we're drawing a line, we're going to the end of the line, we're rotating a little bit, and then we're putting another line, and then we're repeating that step. So we need a variable to hold the angle that we're going to change each segment, and that's what theta is. And then if we want to adjust the stroke weight so that it's a thicker line to begin with, and then it gets thinner as it gets to the end, we can use a variable for that. So once we have our constructor variables, we can do our method here. This.update does all of the math and produces the output. It does the recursion. So when Inside this method, we're going to call the method itself and then pass into it new values. So the value that goes into the argument for the this.update function, it's getting a size and it's getting a tendril, which number of tendril it's on. That size is going to change every time we go through the recursion until there's no more segment length left, and then we'll fall out of it and move to the next tendril. So we want our angle that we adjust the segment to each time we go to the end of a line, we want that to be adjusted according to noise. And if we do our X offset and Y offset right, we're going to get this elephant trunk kind of shape that comes out of the tendril. To make things easy, let's assign a local variable FC that will equal the frame count, and then we can use the frame count to start factoring what our colors are going to be. So I just use some local variables, color red, color green, color blue, using RGB there, and then just map that to the noise. Factor it a little bit. Here I'm using 0.01 for each one of them, but you'll want to change those if you want to get different noise values for each one of the colors. Once we do that, we can start our stroke and plop those local variables down in there, and we can do full intensity for now, and you can mess with the alpha to get different effects here. So I kind of skipped over something in my notes when I was recording the typing of this program. It's easier for me to type it, record that, and then narrate it afterwards than it is to do everything at once. It's just too much for my brain to handle. So just for now, we're going to draw the line to begin with, and then we're going to translate to the end of that line. We're going to rotate a little bit, and we're going to draw another line. And if we have enough line left, we're going to repeat that process. So we translate to the end, we rotate, and then we check to see if we have enough line left, and if we do, we're going to go back into the recursion or perform that method again, except for this time we're going to take a certain percentage of the size of the line that we had to start. So basically the line is getting a little bit smaller each time as it goes down. Each segment gets a little bit smaller until there's nothing left. And then you end up with these tendrils here. So right now I skipped over the stroke weight, so let's go back and do that. I think I should be able to do that. And I have to, did I change the Y offset? So when you go back into the recursion, when you send that back, go back into that method, you want to advance the Y offset, and this is what gives you that really crazy twisting of the tendrils so that you get that kind of elephant trunk appearance. If you have that number really, really small, then it's going to be very relational, very well organized. If you increase that number, then it's going to look more random, and it's going to look more like a spastic octopus. So that's how you can adjust those to get different style of output. So I added the stroke weight, this.sw, which I'm interpolating to the length of the segment that's being drawn. So long segments have thick lines, small segments have narrow lines. And then just adjusting the parameters here, you can see I've adjusted the Y offset so that each tendril is a little bit off from its previous tendril, and you get this kind of delayed movement. And if you delay that enough, it starts to look random. So that's how you can play around with that. This is a really, really powerful and fun generative art procedure. You can just draw where the tendrils ends are. So you could put a condition in there that says don't draw a line unless it's so small. So the long lines, forget about them. I just want the lines at the very end of the tendril. Draw those. And then you could plot that output, and you can be uniform about it, or you can be kind of chaotic like you see here. And maybe have a low alpha on that and just accumulate the output over time, maybe 10,000 frames, 10,000 generations, and see what the mandala, see what shape emerges. So that's it for this project. The code for this is included in the description. There's also a link to P5 Live and the P5 Live tutorials if you want to learn how to use it. It's really easy. It's fun to do. I would encourage you to get involved in it because you can learn a lot more when you can code on the fly, because you can make adjustments and those adjustments happen immediately. You get instant feedback. What ends up happening if you have to run the code like in the regular p5.js web editor, you can make several changes and then you run your code. You don't necessarily want to make one little change here, one little change there, and run it each time you make a change. Instead, you're going to make your 5 or 6 changes and then run your code. Well, what happens is you're not sure which change did what necessarily. So one of the advantages of this is every time you make a change, if it's a good change, like it doesn't cause a catastrophic failure, then you're going to see that immediately. You're going to get that feedback and you'll be like, this change has done that. And then I can make my next change and I know that it's now doing this. So getting that immediate feedback without having to make a change, run your code, make a change, run your code, that's just too much time. This is a lot faster. And also you're in the state that the program's in when the change is made. You're not starting at the beginning and then running the code all the way from 0 through. So if you're like on frame count 10,000 and you like the output where you're at, the 10,000 range of this output, you don't have to run the code and wait to get to the 10,000 range again in order to see what shape has emerged. You can enter that change to the code and it's going to be applied to that generation of output if it can, and most of the time it can, unless like I said, it's a catastrophic change where the program flow needs to be recompiled. So that's P5 Live. That's the mandala maker. Let me know what you think. Leave a comment. Give me a thumbs up if you like this video, if it's helped you. If you know somebody who would benefit from it, please share. Did I say leave a comment? Hit subscribe if you haven't. I would be honored to have your subscription if you feel like you can get some benefit out of these regular recurring videos. And hit the bell to be notified. That's the last part. Thanks for joining me, and as always, until next time, take care.